Before we get going, I have a couple copies of the section 1.5 handout. Does anyone, did they forget yours? I have 4 copies. I'll give away 3 and then we'll have a bidding war for the 4th one if I need some lunch money. Okay, so yes, get those first 3 hands up there real quick. These are the free copies. You never have to ask that question, by the way. You can always just use the restroom. All right, so we got ourselves through exercise 3 on the very front. So we're going to continue. We solved equations. We're going to come back. We'll solve a couple more equations in a minute, but we're getting to a topic that's super similar. We're going to solve inequalities. I'm not going to go through my demonstration if this was an intermediate algebra class. Yes. Sorry, missed your hand. Please remind me from your previous math experience, there is one difference solving an equation versus solving an inequality. Does anyone remember? Can you describe for me the one procedural difference that happens when you have an inequality sign? Yeah. What about the sign? You're right there. Okay, that's what they are. And there's one thing I have to remember about that sign. Go ahead. When? Now it's coming back to you, right? Yes. All right, everybody together, we did it. When you multiply or divide both sides by a negative, not a positive, not adding or subtracting. When you multiply or divide both sides by a negative, you flip that inequality sign. Okay, that keeps the statement true. So that'll come back to you. Here we go. I've got an example for me, and then I've got an example for you. This is example 3. So it goes like this: 3x minus 2, 2x plus 4, less than or equal to 2x plus 1. But other than what we just described, the procedure for solving an inequality is super similar to an equation. So if you weren't here on Wednesday, or if it's been a while for you, hopefully it comes back to you. So remind me, this first step is review. Before, just like with equations, before I even worry about solving, I'm going to make this look nicer. What's the first thing I ought to do here to make this look nicer? Yeah, let's distribute. Let's get rid of those parentheses. It's order of operations. So I've got 3x. Negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. Great. Again, the second step, when needed, is not a solving step. Okay, it's the other part of making this look nicer. What is that I need to do? Like terms, yes. If you remember these steps, there is nothing different on any equation or inequality that I can ever do. Okay, so distribute, collect those like terms. So 3x minus 4x is negative x, less than or equal to 2x plus 1. At this point, this is the hardest solving I can give you. X's on both sides, numbers on both sides. If you can do this, you can do any equation or inequality. Now, remember I told you last time, Miss Hilliard demanded X's on the left, so I'm I'm trained that way, so I'm going to put my X's on the left. Okay, you're talking me through this first one because it's Monday, it's early. Okay, I'm sure you know the steps. What am I going to do to get all my X's on the left? Beautiful. Subtract that 2x. By the way, hey, Perkster, can I put the X's on the right? Yes, of course. And you would if you want to do that. If that's what you like to do, you're going to add the X. But I'm going to subtract 2x and I get a negative 3x over here. When I subtract, do I need to flip the inequality sign? No, good. Thanks for listening. I appreciate it. I got my X's on the left. What am I going to do to get this 8 over here on the right? I'm going to add it. Add that 8. 8 plus 1 is 9. When I add something to both sides, do I flip the inequality sign? Thank you for paying attention. I appreciate it. So now I've got negative 3x is less than or equal to 9. What do I do to finish this out? Okay, there's a key word. You divide by negative 3. I'm writing the step out because this is the important one. This is the purpose of my example. This 3, it's a negative. So when you divide or multiply both sides of an inequality by a negative, instead of a less than or equal to becomes greater than or equal to. 9 divided by negative 3 is negative 3. We are also going to write our answer in interval notation. Okay, we practiced interval notation in section 1.2. So this says all of my x values, all of my answers are bigger than or equal to -3. So if everything is bigger than -3, is -3 the lowest part of the interval or the highest part of the interval? It's the lowest. Oh, I love all the voices. You guys are doing great. And then infinity over here. What am I putting at the -3 end of the interval? And then at the infinity end? Oh, yes. Had some people walk in. Does everyone have the section 1.5 printout? Does anyone need it? Okay. If you don't end up having, grab it like that. Okay, so here's one for you. I'm going to give you a minute or two to work on this problem. So this is exercise 4. 6x plus 2 plus 10x is greater than -2, 2x plus 4, and then plus 10. Okay, I'm going to get started. If you're still working, keep working. Okay, remember I try to cut the difference. Okay, some people are fast, some people are slow. Everybody is doing exactly what they should be doing. Okay, so first things first, I'm going to make this look nice. I'm going to distribute first. I always do the same thing. That way I'm always confident, especially when you get on the test and you're under a little stress. If you've conditioned yourself to do the same thing every time, you're gonna have a lot better chance of success. So here we go. I'm going to take care of those like terms in a minute, but first thing I'm going to do is I'm going to distribute. Now I'm going to collect the like terms. So 6x and 10x is 16 of them. And then over here, -8 plus 10 is +2. You doing all right? If you got a question, raise your hand. Let me know. I want to make sure I'm helpful for you today. Okay, so I'm an X on the left kind of guy. If you put your X's over on the right, we will end up with the exact same answer. Okay, there will be no difference between what we see. So when I put my X's on the left, I'm going to add that 4x, and I've got 20 of them. And when I subtract 2 from both sides, I get 0. And I've added and subtracted. So do I do anything with this sign? No. Nope, the sign stays the same. And then I'm going to finally divide by the 20, and I've got x is greater than 0. That's okay. 0 is a number. That's usually the amount of money in my wallet. Okay, so don't be afraid of it. And so x is bigger than 0. So once again, all of my solutions are bigger than 0. So is 0 the lower end of the interval or the upper end of the interval? It's the lower once again. And this time at the 0 end, what are you going to put? A parenthesis. There's no equality. Any questions about the inequalities? I've given you 2 of the harder inequalities. If you can do those, then you can do a lot of the ones on the homework are simpler, fewer steps. Okay, so if you have a question, ask it. My next example, there's another type of inequality that we'll sometimes see. It's a bounded inequality. So it looks like this. I've got -2 is less than 5 plus 3x, less than or equal to 20. So notice on this inequality, there's not just a lower bound like there was on this one, there is a lower and an upper bound. Okay, sometimes they're called a betweenness inequality. Okay, so here's my question to you. I'm pretty sure if this was the question right here, I'd get unanimity. That's how you say that word. I pronounce things poorly. What am I going to do to solve this inequality right here? Okay, subtract 5. I'm going to write that down. Awesome. Then what I'm going to do, what I'm going to do to solve this inequality is now instead of 2 sides, it has 3 sides. So instead of just subtracting 5 here and here, I'm also going to subtract 5 here. You do the same thing to all 3 sides of the inequality. What you do to the center, you do to both the lower bound and the upper bound. So if you can remember that, solving this inequality is no different than solving any of the others. So -2, -5, that's -7. And I've got 3x in the middle. And then 20 minus 5 is 15. So far, so good? Well, once again, just because I'm repetitive, if this was my problem, what would we do to both sides of this inequality? Yep, once again, I'm going to write the step down because now instead of just 2 sides, I have 3 sides, and you do the same thing on all 3 sides. If I was dividing by a negative, you would flip the signs, both signs, okay? So it works the same exact way. There's no mathematical differences here. Okay, so now I have -7/3, but I divided by a positive, so I don't have to do any flipping of the signs. And then 15 divided by 3 is 5. I've got a lower bound, I've got an upper bound. So when I write this in interval notation, -7/3 is the lower end. It says all of my x's are bigger than -7/3 and also at the same time less than or equal to 5. And there's my interval. So right next to it on your page is a betweenness inequality for you to do. Same sort of thing. Do it. You got a question, ask it. That's why we're here and all together. What's the first thing I'm going to do to all 3 sides of this inequality? Perfect. So when I add 2 over here, I get -6. When I add 2 here, that cancels. When I add 2 here, I get 16. Are we all on the same page still? What am I going to do second? Divide by 4. So when I divide by 4 here, I've got -3/2 is what it's going to reduce to. It'll be -6/4 becomes -3/2. If you're a fan of decimals, it's -1.5. And then we have divide by 4 here, we just get x. Divide by 4 on this side, I get 4. So pretty much the same sort of problem we just did. I just like for you guys to go through and figure one out so that helps you remember. So we get -3/2 and 4. Those are my endpoints. Parenthesis, bracket, there's my interval. Flip over to the back. The next one is just another inequality. It's not a betweenness inequality, but I just wanted to make sure we review and remember the idea of clearing our fractions. So we talked about that on Wednesday last week. So clear the fractions of that inequality and then solve what's left. Thinking back to Wednesday, the way I treat fractions is I prefer to just clear the fractions. And so we talked about the way you clear the fractions is you multiply everything by the common denominator. So what's my common denominator here on this problem? 14. Okay, we've got a denominator of 2, denominator of 7. Remember, you can use any common denominator and always just multiply them together, but sometimes those numbers get big, so you want to use the least common denominator, which in this case is the same thing. So I'm going to multiply everything by 14. Now here, probably, I'm hoping you don't make this mistake, but the mistake I see most often on problems like this is forgetting that, oh, this isn't a fraction, so we ignore this term over here. But remember, you have to multiply everything. Okay, you can't change the problem. Everything has to be multiplied by 14. The 14 I'm multiplying by, is it a positive 14 or a negative 14? It's positive. So do I have to flip the sign? No, only when you multiply by negative. All right, so here goes. On my first term, what happens between the 14 and the 2? What's left? 7. 2 goes into 14, leaves 7. 7 times 3 is 21x. The second term, what happens between the 14 and the 7? Yep, 7 goes into 14, leaves 2. You can use your calculator for that. 14 divided by 7 will leave 2. So now 4x times 2 is 8x. And on the other side of this, negative 5 times 14 is negative 70. All right. I think so. So then 21 plus 8, that's 29x. The rest of this is kind of a letdown. We've done the hard part to that. Always the fraction seems to be the hard part. We divide both sides by 29. It's a positive 29, so that leaves me negative 70 over 29. That's kind of a wild fraction. We've seen this already a couple times. This is my x's are bigger than this. So whenever all my values are bigger than something, that means this is the lower bound. So the lower bound of this interval is negative 7 over 29. Infinity, I've got an equal sign. I put a bracket. Yeah.
When you divide the plus and the sign, you get
what's the sign on the 29? Positive. Doesn't matter what the sign on this is. This is a fantastic question because that's sometimes something we get convoluted. Does not matter what the sign of the result is. It only matters what the sign of what you're dividing by is. So since this was a positive 29, we did not need to flip the sign. Okay, awesome. Thank you for asking that clarifying question. All right, the next, there's an equation right below that. Go ahead and solve that equation. Example 4, the one on the left, please. Oh, you know what? I changed the numbering because I added a problem in. I'm sorry. Yes, it's example 5 now. That will not be the first mistake I make today. It will not be the last. There's my second mistake. Yeah, I'm going to get started on this because I don't want anybody getting confused by this special situation we have here. So I'm going to go through the same steps that we've talked about. I'm going to first distribute. So I have 5 minus 4x, and then negative times 9 is negative 9. Negative times 9x is negative 9x. I'm going to collect those like terms. 5x minus 9x is negative 4x. Now, the more of these you do, you probably can recognize at this point, but I'm going to do one more step, and then I'm going to tell you what we have here. So again, just like Ms. Hilliard taught me, I'm gonna put all my x's on the left. And so when I bring all the x's to the left, when I add 4x, let me write it out. What do you notice happens on both sides when I add 4x? Cancels on both sides. So when your x's cancel on both sides of the equation, you have a special situation. Okay, so I'm just gonna now, there, everything's canceled. So I'm just gonna write what's left over. Whoops. On the left, I've got 5. On the right, I've got -9. Notice there's no more x's. There's no way, there's no term here with an x. There's no way for me to make both sides equal. Is 5 equal to -9? Is that a true statement? No, that's a false statement. When you solve something and all your x's cancel and you no longer have a place to put a value to make both sides equal, what this is called here, this is called a contradiction. What this is telling you is that back in the original equation, no matter what x value you ever plugged in, you'd never get both sides equal. Okay, they're off balance to begin with. So because it's a contradiction, because there's no x value that would work, there is no solution to this. And the way we write no solution is we have an empty set. Now, I told you before, no, that might have been my other class. There's 2 ways you can write the empty set. If I haven't mentioned it, I just go ahead and write some squigglies with nothing in between them. That's fine. The other symbol is called the null symbol. It's like an olive with a toothpick through it, like that. Pick your favorite. Don't use both. If you use both, you're communicating something you don't mean to. Okay, so pick one or the other and then forget the other one. Okay, that's, well, it's a set theory thing. I majored in set theory when I was in college, so now what you have is, this is the way you start to build up. You can use sets to create the whole foundation of mathematics. Okay, you don't need to know that, but I feel like I studied it, so I feel special. And so this begins to help you develop the foundation of mathematics. Okay, this is how you would represent the whole number 1. Okay, in set theory language, and then you build up from there, and it's quite fun. So anyway, so this does not mean empty set anymore, because what you have technically is you have a set, but it has something in it. Okay, it's not empty. So don't use both. There you go. All right, there's one more equation we're going to solve, and then we're going to finish this section with a couple of graphs, because one of the most important skills you're going to have and develop in this class is the ability to read graphs. Super important. Yes.
What happens when there's a contradiction on an inequality?
Same thing. Well, what you would make sure, the question was, in case you didn't hear it, what happens if I have a contradiction and it's an inequality? So if this was an inequality and you end up something like 5 is less than -9, again, you'd make the same assessment. Is this a true statement or is this a false statement? Well, it's false, so it's a contradiction, so there'd be no solution. Okay, if you end up with a true statement here, well, that's what we're getting ready to talk about next. Okay, so the inequalities function no different than equations. That's kind of my promise to you, except for that one thing we do when we're solving. So do the problem right next to it, please. It's exercise 7. Okay, I'm going to get started on this just to explain what's going on. So here we go. First thing I'm going to distribute. So I have 3x plus 6, then negative 5x minus 10 is equal to negative 2x minus 4. I'm going to collect my like terms. So 3x minus 5x is negative 2x. 6 minus 10 is negative 4. Again, after you've done a couple of these, you can probably recognize what's happening at this point, but I'm going to do one more step. I'm going to put my x's on the left by adding the 2x to both sides. And we notice once again what happens when I add my 2x to both sides. X cancels everywhere. Okay, but this time my conclusion is going to be a little different because what remains on the left is negative 4. What remains on the right is negative 4. This time, is this a true or a false statement? True. They're both equal, right? And there's no x here to ever make it different. So it's always going to be true. So when your x's cancel on both sides and you end up with the identical thing, this is called an identity. What the identity is communicating to you is that no matter what x value you plugged in at the beginning, it's always going to be true. You have the identical thing on both sides. And so the solution to this is all real numbers. And when we talked about interval notation, we talked about how to write all real numbers. It is negative infinity to positive infinity. Those are the two special situations. Yes. When you have all real, no, this is not the interval notation. This is what tells me it's an identity. Okay, right here. So when you end up with the same thing on both sides, that says, oh, it's an identity because that's always true. Negative 4 equals negative 4. It can never be different. So that tells me that the solution is all real numbers because this is always going to be true. There's never anything that's not going to make this true. And so that's the interval right there, negative infinity to positive infinity. Any number you want will work. Oh. Okay. So if you go back here, if you don't believe me, and you got some free time this afternoon because we're all just so bored, pick a couple values. Pick 8, pick 19, plug them in. No matter what you plug in for x up here, you're going to end up with the same thing on the left and the same thing on the right because it's an identity. So far, so good? All right. So now we're to my favorite part of this section. I like when we get to talk about graphs. If anybody's going to watch the video, I'm really sorry about doing this. The IT people have not done what I asked them to do with the computer, so I have to call them. So this, I don't even know if that's going to show up. So I'm really sorry. Okay, so here's what I'm going to do then. I'm going to do my best to draw this graph on the board, and then we'll go from there. So here's my example. This blue graph, one thing I left off of the thing because I couldn't figure out how to do it. The blue graph, I would like you to put a label there, g of x. Okay, that graph represents the function, the relationship for the function g of x. And then the red graph please label f of x. My graph is imperfect, but it's got the information I need for you to have. Okay, so below that graph, that example 6, there are two things we are going to solve. So instead of having the equations printed out for us, we are going to solve this using and being able to read the graph. So the first one says, I want to know when f of x equals g of x. Now, before we do this, I've got a couple of questions just to lay the foundation. When you see this notation, f of x, what value does f of x represent? Does this f of x, does this represent the x value or the y value? Y value. The x is the input, it's right here. Then the f of x, the function value, is the y value that comes out. So I just want to remind you that this is the y value. So what you're looking for on the graph is the place where the y values are equal. So describe that for me. At what place on this graph are the y values equal? What's happening? Perfect. When the lines cross, where they intersect. At this point right here, we have the equal y values. Everybody tracking with me? This is super important. So if you can do this, great. If you're struggling, practice this. Okay, reading graphs is something we're going to do all semester. So what we are going to give, though, I don't care about the y value. I just care about where they're equal. What we are now going to give is what is the x value that creates these y values that are equal? What's the input in here that gives the equal y values? So look on your graph. What is the x value at which those equal y values occur? Right here, 2. Would everyone agree with that? At the x value 2, that's where these y values are equal. Everybody locate that on the graph? So good, that's my solution set. 2. So far, so good? Okay, well, you'll get your chance to prove it in just a moment. The next problem says, where is f of x? Still, okay. Where is f of x bigger than g of x? So again, let me just notate this. F of x, I told you to label the red graph. The g of x is the blue graph. So where on this graph, just physically tell me, in relation to this intersection point, am I looking to the left of the intersection or the right of the intersection that has the red y values bigger than the blue y values? Would everyone agree on the right side? Let me just demonstrate in case you're struggling, because I know sometimes students do. Let me pick this x value. Let's compare the y values. Here's the y value on the blue. Here's the y value on the red. Which one's the bigger one, the red or the blue? The red. Here's another one. Here's another x value. I'm just picking values and drawing dotted lines. Again, is the x value on the blue bigger or smaller than the x value on the red? It's smaller. Okay, so what I want to know is where are the f of x values, the red values bigger than the blue? You told me to the right. Okay, so now let's write our answer. 2 is the boundary, because that's where they're equal. Would everybody agree with that? 2 is where they're equal, so it's one side or the other. So I'm going to start my boundary at 2. And then you told me to the right. So I'm going to make this a little darker. These x values, like I was just picking examples, these x values are the solution. So it starts at the value 2 and goes to infinity. Yeah, because they're lines. They never curve back and intersect each other anywhere else. According to the problem that I was asked to solve, what am I going to put at the 2 end of this graph? And what do I always put at the infinity end? Perfect. Do the same thing with the one that's next door. On that one, make the red graph f of x and the blue graph g of x. Same thing. Red is f, the blue is g. All right, so on this graph, okay, where, remember, we are giving the x value that produces these equal y values. So what x value produces the equal y values on this graph? -3, right here. That's where they're equal. So the solution set here is -3. No calculating to do, you just got to look at the appropriate point on the graph. Okay, the biggest mistake on these on the test is forgetting that your answer is the x value that is producing this arrangement here. So once again, I told you that g of x is the blue graph, f of x is the red graph. This time though, I want to know, when is the blue graph bigger than the red graph? So according to the graph, would that be on the left side of the intersection or the right side of the intersection? Where are the blue values bigger than the red? Sorry? Left, yes, right here. So let me just pick an x just to prove it to you. I know they're negative, that sometimes messes us up, but here's where it hits the blue graph, here's where it's going to hit the red graph. Which one's bigger? The blue one is. Alternatively, you can look on this side. The blue graph is below the red graph, so these values are smaller than that. So what's my interval going to be where the blue graph is bigger than the red graph? You told me left, right? Negative infinity, you're giving me the x values that produce those y values. Where does it stop? -3. At infinity, I'm always going to put a parenthesis, and then there's no equality here, I put a parenthesis. Question, comment, or concern? This is a big skill. I know for some of you, no big deal. For others, you're having trouble seeing. I understand. That's why I've got several examples of this skill. We're going to do one more. Down the bottom of the page. Oh, I need to tell you, let g of x, this time I reversed it, sorry. G of x is the red graph and f of x is the blue graph. All right, one more time. There's my graph. What is the x value that produces the equal y values here? Right here, 0. X is 0. There's my solution set. So this time I labeled f of x as the blue graph, g of x as the red graph. So I want to know, where are the blue y values less than or equal to the red y values? So tell me, is that going to be on the left side of 0 or is that going to be on the right side? The blue one being less is the right side. So here's an x value. The blue one is much less than the red one. So that is the side I want. So these are the solutions. These are the x values that produce that relationship right there. So describe that interval for me. Where does that interval start? At 0. Where does that interval stop? It never stops. Infinity, yes. What am I going to put at the 0 side? What am I going to put at the infinity side? Well done.